Okay, so we've got our definition of convex function. Convex. F is convex if f of lambda x1 plus 1 minus lambda x2 less than or equal to lambda f of x1 plus 1 minus lambda f of x2, provided that lambda is between 0 and 1. Yeah, you write that, but you always think that. So I'm just going to rewrite this. F of lambda x1 plus mu x2 is less than or equal to lambda f of x1 plus mu f of x2, with the proviso that lambda plus mu equals 1, and lambda and mu are positive or non-negative, I guess. So, and that suggests thinking about f of lambda 1 x1 plus lambda 2 x2 plus dot 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 plus lambda n xn less than or equal to lambda 1 f of x1 plus all the way through to lambda n f of xn, with the provider that sigma lambda I equals 1, lambda I is non-negative for all I. I can rewrite it in a slightly different way. Sigma I equals 1 to n, lambda I xi is less than or equal to sigma lambda I f of xi, I equals 1 to n, provided that sigma lambda I equals 1, lambda I greater than or equal to 0 for all I. And this thing here is known as Jensens inequality. And it's true for any convex function. The proof is exactly as you'd imagine, which is just stripping off the final one and using convexity of pairs. So it's a relatively straightforward inequality, but it's a very powerful one, and it's quite a nice way of thinking. I'm just going to talk about. I'm just going to make an observation here that x and y. If I draw sine x, there it is. Y equals sine x. I'm just going to make the observation that for 0 less than or equal to pi, which is this value here, it's 2 pi there. Sine x is, or minus sine x is convex, which is the same thing as sine x is concave. And that can quite often be a useful fact to know. So what does it look like? So let's try. Well, of course, you can, for a concave function, you can just reverse the sign of the inequality. So I'll say that sine of sigma lambda I xi greater than or equal to the sum of lambda I sine xi, provided that sigma lambda I equals 1, lambda I is non-negative, and xi lies between pi and 0. So that's quite a nice little inequality all on its own. And I'm going to stop there.